Okay, to begin, I'm going to create a new C++ project. Now, even if you only plan to use Blueprint for the entire duration of your project, I still recommend that you create a new C++ project whenever you create a new Unreal project. The reason for this is, as far as I'm aware, it's usually a safer bet in the long run to have a C++ based project and then start with blueprints, and then eventually if you need extra performance or you need extra control, you can more easily integrate C++ code into the project if it's started as a C++ project. And there are no drawbacks or limitations to the capabilities of blueprints within a C++ project. But if you start as a blueprint project and later on you need extra performance or control, it will be more difficult to add C++ into the project. So it's usually just a safe bet for the long run to start as C++. If you're following along with this tutorial and only ever plan to use Blueprint, I would still say to start with a C++ project, but you can use Blueprint only project if you want. But if you want to follow along, I'm going to go C++, and things will be more similar if you follow along with C++. And there's only a few minor concessions we have to make in terms of startup time and compilation time and creating new blank C++ classes, which I'll show you in a minute. So I'm going to turn off starter content because the only meshes we're going to need are like cubes, so I think we'll be fine without those textures and meshes. I'm going to leave maximum quality on. If you need extra performance on your machine, you can go to scalable 3D, but I think we'll be fine. It's going to be a very simple project for the most part. I'll call this, let's see, I think I'm just going to call mine LPP for Lumines Puzzle Project, and go ahead and create the project. Now, since we're making a C++ project, this might take a little bit longer than setting up a new Blueprint project because it's going to have to create some C++ project files and a Visual Studio solution and get that all compiled, and that can take a few minutes actually. So if this takes too long, I'll go ahead and pause here and get back to you in a few minutes. Now after a minute, the Visual Studio editor will open up, and you'll see at the bottom it says it's scanning the pound includes for additional files. There's, wow, over 100,000 engine files that it's including into the solution here. We will definitely not need to mess with any of the engine code, but I do guarantee that this is worth it in the long run to save you the headache in the future. If you ever need to convert your project from Blueprint to C++, it's just going to save you hours of headaches in the long run when you try to integrate C++ and it gives you a bunch of errors because you didn't start from the beginning as a C++ project. We don't actually need to wait for all this to finish, but I'm just going to wait in case the disk reads and writes going on right now hamper my performance. But when this opened up, you also got a new blank Unreal editor opened up. So I'm going to make a new level, which is completely empty. And we'll go ahead and start populating this with some actors. And we'll go ahead and get started here. Now to begin with, actually, I will wait until Visual Studio is done. Oh, okay, it says it's ready. So now I'm going to, now the one last thing we need to do, because this is a C++ project, just to be safe, I'm going to create base classes in C++ for most of the actors that I'm going to create here, just because down the line, if we plan to add C++, it's going to be easier to have the blueprints already be based on these parent classes, and then just translate the logic from the blueprints to the C++ file, and then test as you go to make sure it still works, and eventually you'll have everything that you want moved over into C++. So we're going to first start by making the grid class, which is going to be the object that contains just the visual representation of the grid. So I'm going to just call this grid. No need to worry about public or private settings in this project. It's going to be relatively simple with only a few classes, so no need to worry about that for now. Now this will open Visual Studio again and add in the new header file and C++ file. But we're just going to leave those entirely untouched. Just the boilerplate that it contains is all we need. We're not even going to look at the C++ for now. Just say, okay, there it is. Good. But we don't even need to look at these. We don't need to worry about the C++. Now let's begin by adding the first blueprint class, and to do that we're going to create it as a child of the C++ class we just created. I'll just call it, the convention I use is to just append _BP to every blueprint class that I make based off of a C++ class. And I'm just going to put it in the root content folder. The grid actor will contain just some elongated cubes to form the rows and columns of the grid, as with most block-based puzzle games like Tetris and Lumines. There is a grid of, kind of like this grid of spaces that you see here in the editor grid, but there's a rows and columns where the blocks can be fitted into. So in Lumines, the number of columns is 16 and the number of rows is 10 as far as the actual spaces where the blocks can fit in. But that means we're going to have 17 cube columns and 11 row cubes to create the 10 by 16 squares, because you need one extra to fill out the last row or column of blocks. At this point we need to make some decisions about the layout of our game and the orientation of everything. So I'm going to go with a coordinate system like this, where Y is coming into the camera and X is directly right from the user's perspective and Z is straight up. So I'm going to position the camera facing down the Y-axis, so along the negative Y-axis, down the negative Y-axis. X will be to the right and Z will be up. There's no real reason that I'm doing this, it just seems more natural to me, but if you prefer another orientation, you're totally welcome to do that. But I'm just going to look at this down here to make sure I'm orienting these properly. And so also in the local space of the grid blueprint, we want to make sure we're using the same axes, so that when we set up our grid visually here, it'll match the orientation in the scene. One last thing before we get started. You don't have to do this, but I'm going to go to project settings and go to let's see, usage. I'm just going to click don't send here, because we're not going to need that for such a small project. But I'm also going to go to my editor preferences and make sure that under usage I'm not sending data to Epic, just because I don't want any extra performance hogging things where this runs a process that periodically sends data. I just don't want to deal with that right now. And I'm also going to go to autosave settings, and I'm going to increase or decrease the frequency so that it's once an hour instead of every 10 minutes, and increase the warning, just because I don't like autosaves happening when I'm unprepared for them. But I do, to compensate for reducing the autosave frequency, I save more often than I probably need to. I save and compile after every time I do anything, just to be safe in case the power goes out. But don't rely on autosaves in general. You should always save things manually and back things up regularly to external storage or the cloud or whatever, just to make sure you won't lose your hard work. That is the worst thing that can happen. Among the worst things that can happen in any sort of software development is to lose hours and hours of progress because you didn't make a backup. So now let's get into this. So the grid here. This grid is going to represent the 16 columns and 10 rows that make up the play area in Lumines. Now what we could do is just add a bunch of static mesh components. I need to make a basic shape cube here since I did not include the starter materials, the starter content. So I could, call this grid column 0 or whatever, and stretch it out and make this the first column element, and then I could duplicate it with a Control-C, Control-V, and move it over by, say, 1,000 or whatever. Oh, that leads me to another point where we need to start deciding what the scale of all our objects is going to be. Now, it's another thing that doesn't really matter, like the orientation. I mean, the orientation does matter, but it's a bit arbitrary whether you choose to do it like this, or any orientation. It's really up to you, but I'm just going to go with what I said earlier with X to the right and Z up. We could have these things be, on the scale of 1 or 100 or 1,000 or 1/10 or 1/100th. It's really up to you. There's nothing that's really preventing us from doing any particular size, so just pick what seems right to you, what feels good. I think I'm going to go with just a scale of 1, and we'll see how that goes. We will base the size of our block actor components on what the grid size ends up being in the world space. But for now, we'll just make the grid and then see what size we need to make the blocks. So we could do this and make the components explicitly like this, create a copy, and just keep moving them over by the same amount. And this will work fine, but I would rather construct the grid dynamically in Blueprint so that we can, in the future, you can adjust the size and shape of your grid if you decide to make tweaks to the game or make your own puzzle game based on Lumines. If you want a different grid size, it'll be much easier to change the space between the grid blocks and to change the general layout of our grid if we construct it programmatically in the blueprints. So I'll delete these for now. And let's go over to our construction script to set up the grid layout. If we use the construction script, then all of our logic here will be reflected in the viewport, and that way we can see how our layout is coming along. So we'll drag out from the output pin here, and we'll type add static mesh component. We'll leave manual attachment unchecked, and we'll just get actor transform. And so now we need some sort of offset to start creating our static meshes. So if we decide on a distance between the rows and columns, then we'll use that here. So let's just say no vertical offset, or say no. Yeah, sure. Let's say vertical offset. We'll make this a vector. You could just make it a float, but I'm just going to use a vector for simplicity here so that we don't have to add a vector to a float. We'll just say in the z-axis direction, we will make the offset 100. Let's just try 100, see how that works out. Also, we'll make a horizontal offset, which will be the same distance, just in the x direction instead. And we'll also need a num columns and a num rows, which is just how many columns we're going to have. Now this is going to be how many gameplay columns and rows there are going to be. So for the construction purposes, the number will be 1 greater. So let's make a note of that right now. Also, this can be an integer. I don't know why I picked a float. And so I'm going to put a tooltip here. I think it's very helpful to always comment as much as possible. If you want to come back a week or a month later to this project, you're gonna be thankful that you added a bunch of comments so that you'll remember what everything was for. I'm just going to write the number of columns in the grid. I mean, that's probably a really unnecessary comment, but that's good. Just get in the habit of commenting everything. We'll also make num rows. Let's say the number of row slots in the grid and the number of column slots in the grid, as opposed to the number of actual cube meshes to form the columns and rows. And the number of columns is going to be 16, and the number of rows is 10. We'll start just adding, 2 column cubes, and then we'll refactor this into a for each loop or a for loop to create all of the necessary cubes. It's time for another decision to determine how we're going to structure our code here. Now, if you want to, let's use these, if you can see them in the video, let's use the blueprint editor columns and rows here just to talk about the shape of our grid. Now, if you imagine this dotted line that I've formed with my drag and select here, if you imagine this is a 4x3 gameplay grid, then if we want to start somewhere, we need to, a route to start the offsets from. I'm going to pick the bottom left corner, so where my mouse is right now is going to be where the default scene route is located with respect to all the cubes. So the route is 0, 0 there, and so the 0th cube for the column cubes is going to start here and then go upwards, and then the next column over will be to the right, and then to the right, and then same with the rows. The 0th row cube, I'm going to start right here, and it will start here and be located to the right of this, and then the rest of the row cubes will be up numbered, the 0th one here, and then the first row cube will be above this one, and then the next one above that, and so on. Okay, let's get some cubes in here, and then once we have some cubes, we can start messing with the scaling and the spacing and get that looking right. But first we need some shapes. So we add a static mesh component, and then we need to set the static mesh of that component. Now, because I did not include the starter content, I'm not going to be able to select a cube mesh here. So to work around that, what I'm going to have to do, I think, is temporarily add a cube here, and then just press the magnifying glass here to find the cube in the content browser, and that's going to open up some previously hidden engine content folder with the cube mesh here. I'm just going to make a copy of this if I can, and just move this into my content folder. This isn't really necessary. I could just reference the one that's here in the engine content folder, but I'm gonna just make my own just so that I don't have to worry about this content folder. Now that's always gonna be there, which is annoying, but otherwise we'd have the starter content here, which, so it's one or the other. Pick your poison, I suppose. So now we have this my cube, which now I'm gonna rename it back to just cube. And I'll go ahead and make a folder here just called static meshes, which is probably just going to have like a cube and maybe spheres later. But for now, I'm just going to call it static meshes. I don't want this content folder to get all disorganized, so I like to keep everything preemptively organized. Now these two files are going to be here, but we'll just ignore them and focus on our content and later our C++ classes folder, but for now everything's going to be in the content folder. So now let's make sure this is the correct cube. Now we have a bunch of things here from the engine, but if we just type in cube here and look at background cube. This is our cube that I just copied. So now we have the cube mesh, and we just need to set the transform now. So relative to the root location, the first column cube and the first row cube are going to have, they're going to be touching the root, but then offset by, well, let's get into it. So first let's split this pin by right-clicking and then clicking split pin. The rotation is going to be whatever, it's going to stay the same. We're not going to mess with the rotation at all. So we'll start with the 0th column cube. So for the column cubes, we're going to move them up and then stretch them out so that the bottom of this cube is touching the root node location. So to offset it, we are going to need to add the, well, it's going to be half of a grid size. It's going to be half of the entire grid size, if that makes sense. So it's going to be, let's think about that for a moment. The grid is going to have 10 slots, right? And 11 cubes that make up those rows. So there are 10 rows of slots, which means there's 11 cubes forming those row separators, which means the middle one is going to be, it's going to have 5 above it and 5 below it. So if we move this cube up by 5 offsets from the root, it's going to be, well, it'll be halfway, which is what we want. So let's just try that out, see if it works. So we move it up by 5 vertical increments. Which 5 is just num rows divided by 2. So to keep this dynamic, let's do that. If we change this num rows to 12 or whatever, this will still be correct. So 5 plugs in here, convert it to a float. And now this will move the location of this mesh that we want to create up 5 rows. Well, first of all, I need to do this. This will probably be wrong. I need to add the location of the root component, like so. So relative to the root, we're going to move up 5 rows, and then that location is where we're going to spawn this cube in. Blueprint organization is a bit of an art more than a science. It just depends on how you like, if you like everything to be straight across horizontally, or if you don't mind like moving down to the right as your blueprints get created. But you'll get a feel for how I like to lay my blueprints out. I try to keep them the way that feels, straightforward to me and organized, but that could be an opinion based on what you think looks cleaner. But there really is, it just depends on the conventions that you as an individual or as a group of creators choose to agree upon for what works best for your environment. But I like to keep things a little bit like aligned and in like a grid shape, usually like straight across, or converging on a central point. And then I like the execution pins to go straight across usually. So these values are going to be the same as the root, inherited from the root. And now this is just going to look a little ugly, but I try to keep the connections from overlapping. Try to limit overlaps as much as possible. But at some point, you're going to have to cross the streams a little bit. So let's see if this even did anything. See, now we have a cube that's up from the root a little bit, which is what we want the first column row to be here. The first column cube will be like this, and then the next one will be right there, and then the next one will be there. So far that seems okay. Actually, the scale is not going to be inherited from the root. What we want to do is actually set that specifically for the column cubes. So we can just test out different values to see what will work. But let's try the number of rows. So let's just try 10, see how that works. It might need to be 5 actually. Okay, so we'll add a few more before we get a feel for how correct that is or how incorrect that is. I'm going to thin it out a little bit by just trying like 0.2 maybe to make it thinner. And then now we need to sort of replicate this logic but change the location value so that it will be offset. So I think what we need to do here is a for loop of some sort. Now, basic for loops like this are a situation where C++ is significantly better for laying out the logic, but I think you'll see that it's not that much worse in Blueprint, and if you organize things nice and neat, it doesn't take that much longer to actually read what's happening once you just get a feel for how blueprints are laid out in general. So we're going to want the for loop to run from 0, which means no offset from the root, to, now because we're making the columns, we want 16 columns or 17 actual cubes. So if we go from 0 to 16, that's going to be 17 total iterations of the loop. So we're going to go from 0 to num columns, which should mean we'll run 17 times, but off by 1 errors are so common, I may be doing this incorrectly, but for now we'll see if this ends up being what we want. So to modify the offset here, what we're going to want to do is multiply, well this number is going to stay the same because this is the z component of the offset, and all the column cubes are going to have the same z offset. They're going to have different x offsets though. So now we need to refactor this and break apart the vector. So I'm going to break all these, just break all the nodes. We'll start over. Refactoring is a common occurrence. I'm sure it's annoying to see in a video, to see the video creator backtrack and change their layout, but it's something you should probably get used to doing very often because you want to be building on a solid foundation. And if you don't have a solid foundation, things are going to get exponentially more and more complicated to maintain and expand. So you always want to redo things if they're not as clean or as clear or as accurate as they should be. So the y values are always going to stay the same because we're working in 2 dimensions here for the game logic. So that'll be the same. The z component is what we're changing here with the vertical offset. So I may change the variable type here, but for now I'm just going to take the z component. Well, you know what? Let's just change these to floats. We haven't used them very much yet. Might as well change them now. I'm going to destroy this node for now and change the type for both of these to be floats, because it's only using one element of the vector anyway, so we might as well just change the type to a float. So So vertical offset divided by 2, vertical offset times num rows divided by 2 gives us the desired offset from the root. So now we add the floats together, and this will be our new position in the z-axis. And so I should probably be using the z-axis here. And for the x-axis, this is where the iteration of the loop is going to have an effect. So based on which iteration of the loop this is, we're going to offset by that number, that index, times the horizontal offset, which is the same as vertical offset in this case, but just in case it was not, we will use a separate variable. And we will, so this number times a float will give us the total offset. So just to keep the convention the same as below, I'm going to put the horizontal on top. So well, so let's do float times float, and this will give us the total offset from the root position. So now we need to add these together. Now I'm going to immediately break that convention by having the actor's root position be on the bottom here, but that doesn't matter. Just try to keep things clean and prevent all the crossing wires. Now to review this logic here. This represents the x, y, and z values for the location of the root, which is this orb here. Whoa, hello. Okay. So, it worked, kind of. So here's the bottom left corner of the grid. And right now our perspective is the same as the camera's perspective in the world. So this is the columns of the grid being formed by the cubes that we've just iterated through. So if this logic is not totally clear, let's review it real quick. This is the white root here. And then to move them up so that they are, so this is the bottom left, we want to move each of these cubes up so that the midpoint of the cube is halfway up the entire grid, which would just be half of the number of rows, which is what we're doing here. So we're adding a vertical offset to all the cubes, the same offset, which is just half the number of rows times the vertical offset for each grid slot, and then add that to the starting position of the root, and then we get the z location. And then for the horizontal offset, we're just moving by one offset increment for each iteration of the loop, and placing one, with 0 offset, and then 1 horizontal offset, and then 2 and 3 and 4 and so on. Wow. And then for the rotation and scale, we're going to just keep the same values. Actually, let me rephrase that. For the rotation, we're going to keep the same value because they're all going to have, no rotation, just the same. We want them to stay, arranged like this, so no rotation. And then for the scale, we'll have to decide what looks good. But for now, I'm going to shrink these a little bit more. So let's try like 0.02. Is that going to be too thin? Probably. Can't really see them here, but it's hard to know what that'll look like specifically. Let's fatten those up a little bit. Let's try 0.05. We do want them to be thin because we want the actual blocks to be the main focus, and the grid is just, guidelines for where the player can move their blocks and place their blocks, but we want them to be visible, obviously. So this handles the column creation, or the cube columns, the column cubes. Now we need to do the row cubes, which is going to be very similar, but switch a few variables around. So we can do a sequence here, if that seems clearer. So we'll add a sequence node here to the blueprint, where first we draw the column cubes, and then we'll add the row cubes. Now I'll go ahead and pull this up a little bit so that things kind of stay straight. And now we will add the row cubes. So let's copy. I think we can copy all this logic and then just change the variable names around. Maybe move some of the nodes, the green wires. So let's try this. For those who obsess over organization, I'm going to try to get this exactly straight along there. And let's see here. We're going to go num rows instead of num columns because we're making the row cubes. Now, the Z component is what's going to change now, and the X component is going to stay the same because we want these to be 1/2 of the distance along the X-axis. It is the same exact logic, just switching the variables around. So you could even do something like this where we just break these two, grab this, move it down, grab this, move it up, what's going to be changing is the Z component, which is why we moved the thing tied to the index down to the bottom. So we could just do this. And theoretically, that's correct, but I haven't tested it yet, so it's probably wrong. I'm going to swap these around so that it is now very thin along the Z-axis, and this should not be 10, it should be, I don't know, let's try 16. Let's see what that looks like. Okay, it's a little bit incorrect, but getting there. What did I do incorrectly? It looks like it's like 3, 2, not far along enough by 3. So, oh, you know what? It's probably because I didn't switch the variable names here. So if I just switch these to, if I click and drag this and overwrite by just releasing on here, it overwrites that one, and do the same here, overwrite that one. But those are actually the same exact number, so that's obviously not going to make a difference, is it? But it's at least conceptually correct now. Maybe. What we need to do here, obviously, looking back at it now, is that we need to change this to num columns instead of num rows. And that will, because we want it to be halfway across all the columns. So this will be 8 now instead of 5, which was, you know, the 3 difference we needed. So there we go. Now we have our grid. That took probably longer than anyone would have hoped for, but I think things will start moving smoother now. It's got to be exactly perfect. To keep things clean on a top level like this is a top level construction script, we could shrink these down into functions. So you can collapse all this to a function and call it, you know, add column cubes or something to that effect, and then add row cubes for the bottom half here. We could do that. Maybe we should do that. I don't like to clog my function list with a bunch of huge functions, but that's almost an inevitability when you're creating a program with a lot of blueprint functions. I guess we'll go ahead and do that. Why not? So let's collapse this to a function. So highlight everything as we have here, and then right click one of them and click collapse to function. And then I guess you could also do collapsed nodes. That might actually be better. If we're not going to reuse this function, there's no need to have a named version of it. So if we do collapsed graph like this, since it's only a one-time use thing, this might be a better option. So we're not, you know, clogging up our function list here with reusable functions. We might as well just have a collapsed function here. Because if this were C++, you know, all this logic could be done in like 2 lines in a for loop or something like that. So no need to go crazy with functions here. But we can rename this to call it add column cubes. And we can collapse this to add row cubes. And then we don't need these redirect nodes anymore. We don't even really need a sequence anymore. That might make it look more confusing than it actually is, but for now I'll keep it. I think it's fine. And one more time, the reason I chose to use collapsed graphs instead of creating a separate function is that I don't think we will intend to reuse this logic and call it from elsewhere in another blueprint or somewhere else in this blueprint, so I don't think we need to make a function. We can just collapse the graph.